Good day. My name is Brian R. Smith, and I'm a student at Sail University going for my mobile gaming master's. I'm going to take you through some of the vibration effects that I've added into my World War I Flying Circus. So first, just a demonstration of that vibration. So here we got the game up and running on my, it's a Samsung S5, and we can see that it's Baron von Red's turn, so he's going to turn to face his opponent. And then Lord Olive is going to do the same thing, turn and face the opponent. So they're both going to get a long-range shot off. So I'm going to play that. And there was a single pulse from the vibration on the phone. Hopefully you can hear that. And then Lord Olive is going to be a little bit aggressive and come directly at Baron von Red. Now Baron von Red hasn't seen his first turn yet, so he's going to play and get his shot. Get hit with the enemy's shot. Now Baron von Red is going to make a fatal mistake here. He's going to turn away from the action, trying to flee. And so I'll play that and double pulse. So now the Lord Olive is it's just a single, 2 hexsides away or hexagons away. And so now it's a double pulse of medium damage. And the Baron is going to make the same kind of mistake again. He's going to turn away from the action. And now it's Lord Olive's turn. So he's moved in closer, got another shot on the Baron. He's going to move even closer in still. And notice it's no pulsing because I only pulse it when your plane gets damage. So there, Lord Olive knows that he's shot down the Baron. Now it's going to be passed to play, and the Baron, of course, doesn't know about this yet. So the Baron's going to play. And there, buzz, buzz, buzz is the Baron's plane getting the most damage, and then of course also being shot down here. So that's the effect that I was looking for, and that I programmed in my World War I Flying Circus. So what I'm going to do now is I'm going to share my screen, and we'll do the Visual Studio application and share. And so here's the code that makes that all happen. So this is all inside this calculate shot damage. And I want to make sure, the calculate shot damage does its business to make sure that the enemy aircraft is facing the other aircraft. And so then the shots can actually happen. And it does a calculation of the distance between the 2 aircrafts. And I've got the close range, the medium range, and the far range kinds of shots. And once I confirm that indeed a hit has been against this aircraft, I then call this vibrate shot, which is a routine that I'll take you through down here. And I do it with basically indicating the amount of damage that's been done. So this again was the close range, so it's the greatest damage, the 3 pulses for kind of a longer duration. This is medium pulses, and then down here is the lightest of the pulses. And I can reconfigure this. I've got some constants up on the top. Again, I'll take you through to that for the reconfiguration. What I do here, I added this kind of recently, is I've got a compiler directive so that if it's not a standalone, then I will call this vibrate shot, because then you're on some kind of handheld device. But basically, if it is standalone, I want to just have this not even execute, or not even be there for the compiler to execute, just saving a little bit of CPU as we're going through this. The sooner I can stop the calls into the vibration. If there's no vibration there's no need to have a series of calls and then kind of roll back to say, hey, I didn't do anything anyway. So do that for all 3 levels of the shooting. Then down in vibrate shot, right here, basically it's the target. So I'm interested to see if the current player is the target, because remember, I only buzz if you're the one that's getting hit. So I do that kind of logic right here. And then depending upon the damage, I'll either vibrate this pattern for close range, or pattern for medium range, or this pattern for long range. And these patterns are actually an array of integers. And it'll take you up until the right here are these different the different patterns that I have defined. And you can see here the different patterns. The first number is the delay before the first pulse. And for all those, I do 0 delay, so just hit it right away. This is the length of the pulse in milliseconds, so about 1/3 of a second. And then you can tell there for the far away shot, I only do for 1/10 of a second. This is the delay between the pulses. And then you can see I can hit the user again with a another 300 millisecond pulse, a third of a second, a little bit less than a third of a second, another delay, then the third of a second. So you can see I can adjust this very easily by changing the code here, and then the pulses will happen at different intensities and different durations, or different lengths and different pauses in between there. So this is the code inside. I've created a separate file, a C# file called Vibration. The code is here. I will freely admit and have to admit, this bit of code here is very much copied from the internet point of view. I don't think I could have, in a year's worth of study, been able to really create this kind of code. I did read up on the documentation about what this all means in the Unity manual, but to be able to do this, somebody else maybe a tad bit smarter than me figured this out, and so indeed I copied that, and I do cite the GitHub resource for that. But then after that, basically it's pretty simple. I've got the vibrate, and there's that array of longs, and I apologize, I said ints, but the array of longs that's being passed as the pattern. And then this repeat is this is used by the Android, on the Android side of the business, for the pulsing. So basically we have some additional kind of logic to say, if this is an Android device, we're going to behave one way. And if it's not an Android device, then it's probably an iOS device, will behave a different way. And then two, from time to time, what I'll do is I'll say, if we're not a standalone, in other words, if we're standalone, again, I just don't want to even execute any kind of code, because I found there was, I don't know if it's a bug or maybe a feature in Unity, but if you coded this and it was being compiled for a standalone device, I was getting runtime errors. And so that's not, I would have expected Mr. Unity to be able to handle say this device doesn't handle the vibration and not have errors bubbling back up to the who called it. But just to be safe, or not just to be safe, so the code actually runs and works. I have this such that if it is indeed a standalone device, the code is not even a part of the compiler. So the compiler directive takes care of that. So anyway, back to this vibrate, got the information that's passed into it. And then basically, if it's an Android, then I passed this Android call to vibrate to say, here's the pattern and the repeat information. And the repeat, if you notice, I had -1 for that. So it's always no repeat. So it's the pulses that I tell it to do. That's the, I build my own repetition into those pulses. So then it's the call to Android, and then in this case, if it's not Unity standalone, then it's most likely iOS, and then we just default to Unity's handheld.vibrate, which then just pulses the iOS, just the single once. And there's a little bit of logic here that is to say, is this Android? And so it's also using the compiler directives to conditional compiling to be able to return either true or false with that. So other bits and pieces that I commented out because I don't use them. I want to keep them around in case I ever decide I do want to use them, but I'd like to kind of try to create as efficient code as possible. So that's kind of a tour of the vibration. It, again, took a little while to get all the different pieces parts together. It was tougher than I thought it would be. It would have been just trivially easy, of course, if Mr. Unity would have been able to implement something a tad bit more robust, to be able to just say, hey, do this, and then you figure out, Mr. Unity, what kind of hardware that you're talking to, but it's not that way. And so anyway, there's the quick tour, and I'll stop sharing. And thank you very much. If you have any questions or comments, let me know. Again, Brian Smith, Full Sail University. Thanks again.